So let us try to solve this type of problem. The question is here, find out the current through the 0.6 ohm using superposition theorem. And we will try to implement this in superposition theorem. So what we will do, we will try to take the same copy of this and we will paste it over here. Because superposition theorem says that at any time you will have one source that is there and rest of the source will be replaced by its internal impedances. Correct. So now we have got these two network. What we will do, we will remove this voltage source from here and I will replace it by a short circuit like this. Now to find the equivalent resistance out of this, what we will do is that we can see that these two are in parallel, right? And that will give us equivalent resistance like this: 0.1, 0.6, this one is 10, and here we have a resistance that is a parallel of 5, and 0.1 divided by 5 plus 0.1 is like this. So if we solve this one, 5 into 0.1, so this will come nearly to the lower resistance only. So this is 0.5 divided by 5.5, this is coming around 0.098. So what we can say nearly this is equals to 0.1, so that our calculation can be made quicker and easier instead of solving this. So now the equivalent circuit has been converted like this, 60. Now if I redraw the equivalent circuit, this will be 0.1, and here we have 10 ohm and these two are in parallel. So we will get here again 10 ohm, and this side will have 0.7. So why don't we calculate these together and write down here. So when I say 10 ohm and 0.7 in parallel, so that value is 10 into 0.7 divided by 10 plus 0.7, that is 10.7, and the supply voltage is 60 volts. So that gives what is the current right now. We are asked to find the current like this in this direction, and let the current, this is I1, and let this current, which is the input current, let be I. So the I value is here. So we can calculate the value of I is equal to 60 divided by, okay, this value is 10.7 divided by 10.7, 10 into 0.7 is 7 divided by 10.7, that is coming around 0.654. So 60 divided by 0.754, that will give the total value of the current. We need not to calculate that. What we will do, we need to find what is I1, current parallel rule. If we want to find the current in this, so the opposite resistance will be taken it. So 10 divided by, that's opposite resistance, 10 divided by 10 plus 0.7, that is 10.7 into I. That I value is here and that is over here. So that I value is 60 divided by 0.754. Now this is nothing but 600 divided by 10.7 divided by 0.754, and that's equals to 74.369 ampere. So we get the value of I1 from one source. So because of this source 60 volt, we get the current over here, correct? That is 74.369. Now we have got another circuit over here. So in this circuit, we would like to delete the other side of the source and replace it by a short circuit, because ideal voltage source is represented by zero resistance. And now if we calculate this, find out the equivalent circuit over here, so what we are going to get, this side you can see that 10 and zero point 0.1 are in parallel. So obviously it will replace by a smaller resistance very close to 0.1. So we are writing here 0.1, and this is 0.6, this is 0, this is 5, and here we have 0.1, and this is the voltage source applied here, that is 40. So our objective is still to find the current over here. That, let us say this is I2, and let's say the current which is here, this is I. So let us redraw this circuit with another equivalent circuit. So we have 5 and this resistance are in parallel, 5 and 0.7, and 40 volt is in series. So 5 and 0.7, if we have parallel, so 5 into 0.7 divided by 5.7, this is come around 0.614, and that gives the value of I as equals to, the value of I is equals to 40 divided by 0.714 ampere. So what is my I2 is here, I2 is equal to negative of that minus of, I2 means the, if I say this is I2 over here, so this my negative of the value will come, and this two parallel paths are there now if the current is flowing like this. So we will take the opposite resistance, so that's why 5 divided by 5.7 into I is 40 divided by 0.714, and this will give 5 into 40 divided by 5.7 divided by 0.714 minus of 49.142 ampere. So now we have got this 49.124 ampere, and here we have got I1 value already, right, and here we get the I2 values. So what is the superposition theorem? Is the summation of these two effects, so I1 plus I2, so that will be equals to 74.369, and addition of this I2, which is a negative value, which will give 25.226 ampere. So this is how we can solve this numerical and get the answer 25.226. Now let us solve another problem here from this question set. The question is here like this: two bulbs each of 60 watt, like two bulbs each of 60 watt, and one bulb that is of 100 watt. So I'm writing here just the values. Two bulbs are there each of 60, so total will be 120. So this much of power is being used for 6 hours in one day. So 6 hours, this is per day. So that is a consumption. This is I can say W1. So W2 we have got two tube lights of 40 watts only. So 2 into 40. This is going to be run for 6 hours per day, right? That is, you can assume that the consumption of load in different household. So three fan each of 60 watt, and this is running for how many hours? 10 hours. This is run for 10 hours per day on average. Then you have got W4, which is one fridge, which is a 150 watt, and this is all in watts, right? Into 24, the fridge is running for the entire day, and that's why it is like this. So what is the total energy that is being consumed will be, so that will be equals to this value, that is this. So addition of all these values will be there. So we have got 120 plus 100 and that much into 6. So this we get is this we get around 1320 watt, right? This much watt hour, and then we get here another, this is per day. So 2 into 40 into 6, that is 480 watt hour. And the third one is 3 into 60 into 10, that is 1800 watt hour. And the last one is 24 into 150, that is 3600 watt hour, right? So we get a total watt hours of, the addition of these three is 1320 plus 480 plus 1800 plus 3600. That comes to be 7200 watt hour. I can convert into kilowatt hour as 7.2 small k capital W H kilowatt hour, right? And you know that 1 kilowatt hour is 1 unit, so I can write 7.2 unit is consumed per day. So question is asked in the month of January, so what is the total wattage that is being consumed in the month of January? So obviously 7.2, January is of 31 days, and that gives value of 223.2 kilowatt hour. Now, how you have to pay the electric bill? Like as per the question given here, you have got first 100 units. Okay, the first 100 units you have to pay for like 1.4 rupees per unit, and next 100 unit you have to pay for 2.3, and rest is 23.2 that you have to pay for 3.1. This is a very old tariff, right? 140, 230, and that one is 23.2 into 3.1, 71.92. That gives a value of 230 plus 140. That gives a value of 441.92 rupees. This much will be the tax. This much will be the charges for consumption of that much power in the month of January. Correct. So this is one problem. There is another problem was also mentioned over here. So that problem is like given the data is like 4-pole machine is there, and it is of 3-phase induction motor, and the frequency is 50 hertz. That is given here, and speed at which the question is asked the speed at which the magnetic field of the stator is rotating. So it is, they are asking actually what is the speed of the flux, speed of the magnetic field or speed of the flux, stator flux. Stator flux, we can have a nomenclature like ns, and we know the formula is 120 f by p, and that value is 120 into 50 divided by 4. It comes around to be 1500 rpm, correct? So we have got 1500 rpm, you can see the 30 then like that. So another question is like the speed of the rotor when the slip is 0.4. So when the slip is 0.04, what is the speed of the rotor? You know, S is nothing but ns minus nr by ns. That's the formula of the slip. And if you know that, you find out nr is equal to 1 minus s by into ns, and that gives equals to 0.96 into the ns is 1500. Now the rotor is rotating at 1500 into 0.96, that gives us 1440 RPM. So rotor is running at this speed. So your synchronous speed is 1500 RPM and the rotor is running at 1440. What is the difference? 60 is the speed of the rotor flux. That is not asked right now. So what else asked is that the frequency of the rotor current when if slip is equal to 0.03, what is the frequency of the rotor? Frequency of the rotor is always, remember, S times of the supply frequency. So if is 0.03 into 50, that gives value of 1.5 hertz. 1.5 hertz is the frequency of the rotor. And another is what is the frequency of the rotor at standstill? The moment standstill is said, that means S is equal to 1. So obviously at 1, frequency of the rotor is equal to frequency of the supply, that is 50 hertz. So these are some 3 numericals roughly to this is to explain.